So, you might have heard that Yellowstone National Park is sitting on top of a giant supervolcano. That's a reason why the area can boast powerful geysers and hot springs. But it also means that underneath Yellowstone, there is an enormous magma chamber. In 2015, researchers from the University of Utah found out that this chamber was much bigger than everyone had previously thought. They even found one more reservoir with magma under the top one. Apparently, the more spacious the chambers are, the more magma they contain. Together, the two reservoirs store a glob of magma that could easily fill the Grand Canyon not once, but 11 times. But you know the most worrying thing about the magma chambers? They tend to push against the ground above them. As a result, the land in Yellowstone rises about 1 to 2 inches a year. On top of that, Yellowstone has the status of an active volcano, and its volcanic explosivity index, yes, there is one, is 8 out of 8. Such a high number means that if this volcano erupted, it would be an apocalyptic event. To put it into perspective, the eruption of Pinatubo in the Philippines in 1991, which is considered the most powerful in living memory, was given a mere 6 on the volcanic explosivity index. Ha, loser. Now, let's figure out if there's anything to worry about. In March 2023, the University of Utah seismograph stations recorded 354 earthquakes in the entire region of Yellowstone National Park. Sounds like a lot. But keep in mind that the most impressive event of the month was a mini earthquake of magnitude 3.7. It was part of a swarm of 106 earthquakes that began on March 29th and continued until the end of the month. Yep, earthquakes apparently also come in swarms, so be aware. Experts say that Yellowstone's seismic activity is, well, kind of more active than usual, but it's really nothing serious. A geophysicist working at Yellowstone Volcano Observatory called Michael Pollan claims that the volcano won't erupt anytime soon. For this to happen, there must be enough magma ready to erupt beneath the surface. Whew. There should also be enough pressure to cause this magma to rise. But neither of these conditions exist today. According to the expert, Yellowstone is stable now. At the same time, Pollan and his team are keeping track of all kinds of underground activity, looking for warning signs of possible eruptions. Some of them can be the frequency of earthquakes and ground deformation. Thousands of mini earthquakes, coupled with extreme changes in the surface of the ground in that area, can be alarming. The team also monitors the temperature of the park's thermal features. That's another noteworthy sign of a potential disaster: park-wide changes in geyser activity, as well as gas and thermal emissions. So, despite the media claims that Yellowstone is due to erupt soon because the last eruption happened 70,000 years ago, that's not how volcanoes work. Experts say that it's one of the most popular misconceptions about volcanoes. They don't follow timelines. If a supereruption did happen, though, the most worrying thing for us would not be the lava flows, and not an earthquake that would most likely accompany the natural disaster. No, the worst consequence of such a supereruption would be ash and ashfall. Let's have a look at what it was like when the Yellowstone volcano erupted many years ago. There have been at least 3 supereruptions in the history of the volcano. The most powerful of them was 2,500 times more devastating than the terrifying eruption of Mount St. Helens in Washington state in 1980. As for the most recent supereruption, it was dubbed the Lava Creek eruption. It formed the Yellowstone Caldera after spewing out an insane amount of dust, volcanic ash, and rock into the air. Recently, scientists have also learned about 2 other previously unknown supereruptions that happened around 9 and 8.7 million years ago. The younger of the 2 is now considered to be the largest recorded event of the whole Snake River Yellowstone volcanic province. Anyway, let's have a look at what was going on all those millions of years ago. Because I wasn't around then, so we're all assuming this stuff based on evidence. The first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, the heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust and leaving behind huge chambers. They were filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding since more and more magma arrived with time. The land over the volcanic system was rising upward almost unnoticeably. A year before the supereruption, Yellowstone gave a warning, a burp maybe, but that long ago there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression releases gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging in that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up. This created a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle of soda after you've shaken it. Something like that was happening near the volcano. Think Mentos and Diet Coke. The pressure was released through the fractures when gases were bursting out from under the surface. So right before the disaster, the ground around the Yellowstone volcano lifted. Geothermal pools and geysers heated up to boiling temperatures and got more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore, and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe. But the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash hurled up into the air. Within several minutes, a pyroclastic flow rushed across the area at a hurricane-force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot, expanding gases. It looked like an extremely hot, toxic snow avalanche. With a temperature of about 1,300 degrees, it was burning everything in its path. The volcano kept pumping ash for days on end. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds of being inhaled. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a thick layer of ash covered huge territories. After the ash got into the stratosphere, the temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sunblocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing supereruption, was colossal. That's how researchers described it in their recent studies. It affected a huge territory. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. Now, if such an eruption were to happen these days, it would cover Colorado, Utah, and Wyoming with almost 3 feet of toxic volcanic ash. Many regions would be plunged into darkness. Even the coast, where most Americans live, would experience problems with the spread of the ash cloud. It would destroy crops and contaminate pastures, ruin power lines and electrical transformers. Well, so I'm sure you'll agree with me, it's a good thing that such a disaster isn't expected to occur anytime soon. Hey, we got enough other stuff on our plate. If you've ever been to Yellowstone National Park, you were probably mesmerized by its geysers, which spew superheated water and steam high into the air. But an even more intriguing thing actually hides underground. I'm talking about that underfoot plumbing system that makes those grand eruptions possible. About that, there's good news. Recently, researchers have succeeded in mapping the national park's hydrothermal plumbing system with the help of a giant flying magnet. As a result, scientists have managed to document all these features in stunning detail. The thing is, Yellowstone houses the world's largest hydrothermal system. It contains over 10,000 features, like geysers, mud pots, hot springs, and steam vents. They're fed by a network of underground water pathways. Those get overheated by magma flowing underground. It causes the water to rise to the surface. Now, no one actually knows much about the workings of this system, but the newly created maps might finally shed light on it. Experts explain that their knowledge of Yellowstone has a subsurface gap. That's why it's often called a mystery sandwich. Scientists know quite a lot about the features on the surface because they can observe them directly. And they know what's going on in the magmatic and tectonic system several miles below the surface. But they haven't figured out what's happening in the middle yet. So, I must tell you about that giant flying magnet used for research. It's known as SkyTem. It was attached to a helicopter and flown over Yellowstone several hundred times, scanning the ground below. The magnet is made up of an 82-foot-wide charged wire loop. Its main task is to generate a strong electromagnetic field. And since different kinds of material, like water or rock, respond to this field differently, scientists managed to create a few subsurface maps for the first time ever. The mapping technique also allowed the researchers to differentiate between magma and bedrock, since they have a bit different magnetic properties. And the team got a chance to see how the magma and water interact and create those mind-blowing geological features on the surface. The team got high-resolution maps to a depth of around 500 and 2,300 feet, and low-resolution maps showing what's going on at a depth of up to 1.5 miles. At the same time, the researchers think that the hydrothermal system itself may stretch as far as 3 miles below the surface. If they're right, it means they've only mapped the top half of Yellowstone's plumbing system. Anyway, remember how I said that scientists know pretty much about the bottom part of the Yellowstone sandwich? They have such a good idea about the tectonic plates and deep fault lines because the park's frequent earthquakes provide them with a lot of opportunities to study different phenomena. In July 2021, for example, more than 1,000 earthquakes rocked the area. These days, the team of researchers knows much more about some famous features, like the Old Faithful Geyser or the Grand Prismatic Spring. They've also found out that individual hydrothermal features on the surface can actually be connected to others, which can be as far as 6 miles away from them. Another interesting discovery is that even though Yellowstone geysers and hot springs vary in size, shape, color, volatility, and chemical composition, they are mostly fed by very similar underground sources. That means that the difference between the features appears closer to the surface. Now, I'm sure you've seen the iconic image of Yellowstone with a large rainbow-colored spring, fiery orange at its edges. So what makes these hot springs so colorful? Surprisingly, these awesome hues come from microscopic creatures. The temperatures in the springs are so high, they can easily and quickly cook you. Plus, the water there is super acidic, like the liquid in a car battery. But there are certain types of heat-loving microbes that don't mind these crazy conditions. You can even say they're thriving there. So every ring of a different color is, in most cases, a ring inhabited by different bacteria. And each species is adapted to a particular temperature or pH level, which measures how acidic this or that environment is. For example, take the Grand Prismatic Spring, yes, the iconic one. Its rainbow hues likely hint at the diversity of microbes living there. So, starting from the center of the hot spring, you can see a beautiful aquamarine color there. That's where the water temperature is the highest, reaching 189 degrees Fahrenheit, because this area is right over the underground water source. The water there is too hot even for microbes. That's why what you see is mostly clear water. As for the reason for its blue color, it's the same as why the sky is blue. Sunlight hits the surface of the water and the light scatters, but the blue light scatters the most, getting reflected back to your eyes. Now, the next ring of color is yellow, all thanks to certain cyanobacteria. The temperature in this yellow ring reaches 165 degrees Fahrenheit. If the conditions in the hot spring were a bit different, These bacteria would create a blue-green hue thanks to a green pigment called chlorophyll. But since the sunlight hitting the spring is too intense, the bacteria start producing another type of pigment. It's called carotenoids. And guess what? It acts as a sunscreen for the bacteria. And since this pigment is orange, the normally green bacteria get a yellowish hue. And finally, we've got that bright orange color closer to the edges of the prismatic spring. It's a bit cooler there, around 149 degrees Fahrenheit. In this part of the spring, you can find several types of bacteria. They all produce substances that give the spring this bright orange color. And finally, right at the edges of the spring, the temperature is cooler, around 131 degrees, and a greater variety of microbes can survive there. All of them combined give the edges of the spring that red-brown hue. But scientists believe that people and their activity may have influenced the colors of Yellowstone's hydrothermal features. For example, in the past, the temperatures in the Morning Glory Pool used to be much higher than they are today. That's why its color was a deep blue. But trash has started to accumulate in the pool, and some of it clogged the vent. This caused the temperatures to drop, which led to microbial growth. As a result, that pretty blue color turned into orange-yellow. As for Yellowstone's geysers, the most famous one is called Old Faithful. It got this name at the end of the 19th century because of how regular its eruptions were. This geyser is more active than the others, erupting about 20 times a day. Each of these magnificent events lasts from 1 to 5 minutes, and the fountain of steaming water can reach a height of 180 feet. Now, while talking about Yellowstone National Park, we can't but mention Yellowstone Supervolcano, right? Supervolcanoes appear when huge volumes of magma are trying to escape from deep underground. Eventually, they burst through Earth's surface. Sometimes all this magma gets stuck, unable to break through the planet's crust. And then, massive pools of pressurized magma gather at a depth of several miles. The pressure keeps growing because more and more magma is trying to get to the surface. At one point, a super eruption goes off. You don't necessarily want to be around for that. Over the past 50 years, the Yellowstone Caldera has risen almost 3 feet. It shouldn't alarm you, though. Experts are sure it's a natural behavior for Yellowstone. Periods of dome-shaped uplift are followed by the caldera lowering. Scientists think the supervolcano doesn't present any danger at the moment. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. Even better, a recent study made the researchers believe the hotspot might be in a state of decline right now, even despite all the breathing and dome-raising activity. There have been at least 3 other super eruptions in the history of Yellowstone volcano. They happened 2.1 million, 1.3 million, and 640,000 years ago, long before video. The most recent super eruption was dubbed the Lava Creek Eruption. It formed the Yellowstone caldera after spilling out 240 cubic miles of rock, dust, and volcanic ash. No thanks, I'll pass.
The latest super eruption of Yellowstone occurred 640,000 years ago, and it was long before Homo sapiens saw the light of day. But we were around during another, no less devastating natural disaster. This super eruption took place on the island of Sumatra around 74,000 years ago. That's when an erupting supervolcano wreaked havoc on huge territories, sending up plumes of debris and ash that spread for thousands of miles and caused temperatures on the planet to plummet. The effects of this super eruption were visible as far away as southern Africa. Experts believe they could have impacted early humans there. By the time the volcano erupted, our ancestors had already been using stone tools and had likely known how to produce yarn. And some specialists even think that the Toba super eruption was so powerful it could push our ancestors to the brink of extinction. They claim that Toba might be the largest volcanic eruption to occur on Earth within the last 2 million years. The eruption disgorged so much pyroclastic rock it would be enough to cover the entire United States to the depth of a 1-story house. About a third of that deposit piled up on northern Sumatra, while a lot more ended up beneath the floor of the Indian Ocean. The super eruption left an elliptical crater lake around 60 miles long. The caldera is so large it's hard to feel that you're indeed in a volcano. Pumice deposits from the eruption remain in the canyon walls and go deep below the ground. There aren't many arguments about the amount of pumice and ash involved in this disaster. At the same time, experts aren't sure how much sulfur ended up in the atmosphere. Even some sulfur layers in the polar ice could be potential candidates, but so far, scientists haven't found any connection between them and Toba. But let's get back to the dramatic impact the super eruption had on early humans. It turns out some not only survived but even thrived after this natural catastrophe, at least judging by the artifacts they made during and after the eruption. The disaster might not have posed a serious threat to those of our ancestors who took refuge along the coast. Genetic evidence hints that modern humans descend from a few thousand people that ventured out of Africa around 60,000 years ago. Why just a few thousand? According to some experts, the rest of our ancestors could have been devastated by the Toba eruption. After all, the supervolcano spewed out 1,000 cubic miles of dust and rock in a flash, leaving a scar in the ground that was dozens of miles wide. All that dust and sulfur Toba sent into the atmosphere potentially cooled the surface of our planet, which led to the appearance of glaciers and the lowering of Earth's sea levels. And since Toba might have had an important role in shaping humankind, scientists have been working hard trying to understand precisely how early humans reacted to this disaster. In 2011, several researchers found an enigmatic soil sample in South Africa's Pinnacle Point, an archaeological site overlooking the Indian Ocean. This sample contained some volcanic ash. After examining the layer, they found more than 400,000 artifacts left by early humans. Those ranged from heat-treated stone tools to signs of fire and animal bones. Based on this finding, the team suggested that early humans on the South African coast thrived after the eruption, living in that area for thousands of years and improving their tools. The region might have served as a refuge during and after the Toba eruption. A 2009 study suggested that the eruption could have lowered global temperatures by 14 degrees Fahrenheit. It would have made survival tough elsewhere in Africa. If there had been a volcanic winter, it wouldn't have been as cold along the coastline. On the other hand, newer studies claim that Toba spewed out so much sulfur into the atmosphere that the resulting aerosols could have stuck together, which would have limited their cooling effect in the long term. In other words, right after the eruption, temperatures would have plummeted, but only in some regions. And after 3 years or so, the effects of the eruptions would have calmed down altogether, becoming not dangerous to humans. Well, apparently, more research is needed. Meanwhile, let's figure out if we should watch out for any volcanoes these days. Last year, thousands of small earthquakes shook the ground near Iceland's Svartsengi geothermal power plant. Magma rose to the surface there, and now it has opened wide fractures slicing through the small town of Grindavik. The ground there is still swelling, and an eruption might happen with little notice. But of course, that's not all. Over the planet, 45 other volcanoes keep rumbling. For example, Italy's Vesuvius, that infamous thing that finished the city of Pompeii in 79 CE. Over the last 17,000 years, the volcano has experienced 8 explosive eruptions, followed by powerful pyroclastic flows, dense masses of super hot ash, lava fragments, and gases flowing at high speeds. The volcano's last eruption happened in 1944. Mount Rainier is one of the most dangerous volcanoes in the USA. Its high elevation, chemical composition, and proximity to Washington's Seattle and Tacoma suburbs, and the volcano's ability to produce massive pyroclastic flows make Mount Rainier a threat to consider. The heat from this volcano could potentially melt the ice and snow covering it, leading to rapid downstream flows of debris, mud, and rocks. The Novarupta volcano in Alaska's Katmai National Park and Reserve formed in a 1912 eruption, which was the world's largest in the 20th century. The volcano sent almost 7 cubic miles of ash and debris into the air. It also produced such a powerful ash flow that it created the Valley of 10,000 Smokes. Mount Pinatubo is located in a populated region in the Philippines. It became notorious after a 1991 massive eruption, which was the second largest eruption of the 20th century. More than 700 people lost their lives during that natural disaster. Today, more than 21 million people live within 62 miles of Pinatubo. Mount Agung, a continuously erupting volcano in Indonesia, had its last major eruption in 1963. It was one of the most tragic eruptions in the country's history. It lasted for 11 months, producing ashfall and pyroclastic flows that led to the loss of more than 1,000 lives and serious property damage. People saw ash plumes above the volcano throughout 2018, following the eruption in November 2017. Japan's Mount Fuji hasn't erupted since 1707. That year, a massive earthquake likely set it off. In 2014, experts warned that Fuji could be at risk of another eruption following the 9-magnitude earthquake that shook Japan in 2011. Experts believed the earthquake had raised pressure below Fuji. The eruption in 1707 sent so much ash and debris into the air that all this mass even reached Tokyo. Should Fuji erupt again, it would affect more than 25 million people in the surrounding areas. The eruption of Washington's Mount St. Helens in 1980 was one of the most destructive volcanic events in U.S. history. 57 people, as well as thousands of animals, lost their lives during that natural disaster. The eruption also destroyed around 200 square miles of forest. Experts think that Mount St. Helens' history of massive eruptions means that future catastrophes are bound to happen. The next explosive eruption might send large amounts of ash all over the Pacific Northwest. No wonder the volcano is under close monitoring. One of Indonesia's most active volcanoes, Mount Merapi, has been erupting for centuries. NASA claims that the biggest risk of this volcano is pyroclastic flows, which can spread over vast areas and harm loads of people. For the last time, Merapi erupted in January 2024, sending plumes of smoke into the air. These days, more than 24 million people live in the area surrounding this volcano.
We all know that space missions come with a hefty price tag. To break it down, a ticket to space for an astronaut starts at around $20 million and can soar up to $50 million. NASA may be a well-funded organization, but you can bet they're always on the lookout to cut costs and save millions wherever they can. Plus, NASA has long realized they do not need to go to Saturn's moon to study if there's life there. We already have the suitable conditions for extraterrestrial life in Wyoming. If that resonates with you, then you already understand why NASA is so interested in Yellowstone. To explore life beyond Earth, we need to study environments that mimic extraterrestrial conditions. That's where all those hot springs come into play. Now, it's not the entire park that piques NASA's interest. Let's leave the bears, moose, and other Earthlings to our local biologists. The real hot spot is the geysers, where microbial life flourishes. Oh, by the way, Yellowstone has more geysers and hot springs than the rest of the world combined. In some of them, water can reach temperatures as high as 192 degrees Fahrenheit. You might think, hey, that's only good for steeping tea. But here's the thing. Life in the form of microbes not only survives but thrives in these extreme conditions, having adapted specifically to them. So, could these microbes help us find life on other planets? Absolutely. Now, let's shine the spotlight on the real superstar, the Grand Prismatic Spring. It's packed with silica, which gives it that stunning color. Silica reflects sunlight, especially the blue wavelengths, which is why it looks so vibrant. The coolest part, though, is not the color, but the fact that this spring can teach us a lot about how life evolved. Way back around 4.5 billion years ago, I wasn't around then, living things didn't know how to harness energy from sunlight yet, so they were using chemical processes instead, just like they do now at the Grand Prismatic Spring. But why are we talking about other planets? Well, if life on Earth kicked off in a comparable way to what we see in Yellowstone, there's a good chance we could find something similar elsewhere in the universe. And if we could nail down exactly how life started here, we could really fine-tune our search for life on other planets. Geysers, very similar to those in Yellowstone, can be found on moons like Enceladus, which orbits Saturn, and Triton, which is a moon of Neptune. But how do they compare to the geysers we see in Yellowstone? Well, back in 1989, NASA's Voyager 2 spacecraft made a groundbreaking discovery when it spotted geysers on Triton. This was the first time anyone had seen a geyser outside of Earth, not counting the volcanic eruptions on Jupiter's moon, Io, that were found by Voyager 1 in 1979. Since then, more geysers have been found on other moons in our solar system. In Yellowstone, geysers are heated by hot water from deep within the Earth. However, geysers on some of the outer moons get their heat from tidal forces, the gravitational pull from the big planets they orbit. You know how ocean tides on Earth are affected by the moon and the sun? Well, these moons experience something similar, but on a much larger scale. Beneath the icy surfaces of these moons are warm, salty oceans that stay liquid because the thick ice above keeps them insulated. As the moons move closer and further from their parent planets, the constant tugging creates heat, causing the warm water below to shoot out into space whenever there's a crack in the ice. This icy crust and the warm water underneath are a bit like a frozen pond on Earth. But could there be life swimming around in these hidden oceans, just like there are critters thriving beneath the ice of a pond? That's something scientists want to find out. NASA hopes to send advanced spacecraft to explore these distant moons and look for signs of life. But those warm oceans are buried miles beneath the frozen surface. So, how do we reach them? The answer may lie in geysers. In February 2019, a group of planetary scientists decided to visit Yellowstone in the winter to study the similarities between Earth's geysers and those in space. They know that Yellowstone's geysers are home to some tough little microbes called extremophiles, which thrive in extreme conditions like hot or acidic water. The researchers wanted to learn as much as they could about these microbes and the environments they live in. They brought along a bunch of scientific tools to measure things like temperature, pH levels, and oxygen in the water. They also used special instruments to analyze the chemicals in the ice and rocks and sniff the air for gases. Plus, they collected samples of rock, ice, and water from the geysers, catching tiny droplets on sheets of foil coated in geyser spray. Their main target was the Great Fountain Geyser in Yellowstone's Midway Geyser Basin, which puts on a spectacular show 2 to 3 times a day. However, visiting in winter posed some challenges. Some scientists were delayed by snowy weather, arriving late at night right before they were supposed to enter the park. Then their SUV got stuck in a snowdrift and had to be rescued by a snowplow. The next day, riding in a snow coach, the team had to trudge through deep snow for nearly a mile to reach the geyser, keeping an eye out for elk, bison, and even bears. As they made their way to the Great Fountain Geyser, they took breaks to gather samples and measurements from other interesting pools along the way, like Lemon Pool and Surprise Pool. Even though Yellowstone feels remote, it's not nearly as far away as places like Enceladus and Triton. It's a unique natural laboratory that can teach us a lot about life on Earth and potentially beyond. Oh, as for labs, the Great Prismatic Spring may count as one. Look at these guys. Under the microscope, they look like matches. Their official Latin name is Thermus aquaticus. They live in this hot spring, and these bacteria have saved millions of people's lives. Now, if you're skeptical about what I just said, then you need to know that these bacteria help to create the basis of PCR tests widely used in today's medicine to give fast and precise diagnosis. Back in the 60s, a microbiologist named Thomas Brock was exploring the park's superheated thermal pools and stumbled upon something amazing. Brock was super interested in bacteria that could thrive in extreme conditions. During his 10-year journey studying geysers and thermal springs, he found a microbe in a spring called Mushroom Pool that could survive in nearly boiling water. This little guy, Thermus aquaticus, turned out to be a game changer for science. Why? Well, it's crucial for a technique called PCR, also known as polymerase chain reaction, which is used to quickly make copies of DNA samples. Before Brock's discovery, this process was tricky because the heat could damage the enzymes that hold DNA together. But thanks to Thermus aquaticus, scientists could now heat and cool DNA samples without breaking them down, making everything faster and easier. It all happened because researchers had purified an enzyme called tag polymerase out of this organism. Those Yellowstone microbes could also be your new go-to for a delicious and sustainable breakfast. A unique microbe was discovered there during some NASA-funded research, and it's now being transformed into tasty vegan breakfast patties and cream cheese. Originally found in a hot spring, this little wonder is called Fusarium strange flavolapsus, and it caught the attention of space enthusiasts as a powerful protein source for long space missions. Plus, it requires way less water and land than beef, making it a smart choice for the planet. Researchers initially looked at this microbe for biofuel, but soon realized it could be cultivated into a complete protein with a texture reminiscent of chicken. Marked as FY, it can be turned into a variety of food products, all thanks to a fermentation process that keeps it free from contaminants. Oh, almost forgot. NASA is even working on a bioreactor to grow FY in space. Ooh, stay tuned. So, you notice anything weird? Recently, there have been alarming changes in the water levels in different parts of Yellowstone Lake. At the same moment, the water level can be rising on one side of the lake and falling on the other. Ooh, it looks as if the lake basin gets lifted by some underground forces. Can it be a sign of a looming disaster? Geysers, mud pots, and hot springs turn Yellowstone National Park into some extraterrestrial world. And all these wonders are fueled by a mighty supervolcano. Supervolcanoes produce super eruptions. When it happens, they launch more than 240 cubic miles of ash, molten rock, and hot gases up into the air. To make it easier to imagine, 4 super eruptions could fill the Grand Canyon to the brim. The Yellowstone giant was thought to be responsible for at least 3 enormous eruptions and countless smaller ones. In that region, the volcanic deposits are scattered over tens of thousands of miles. Scientists believe they had been created by many weak eruptions. But after doing more research, experts found out these deposits had been left by 2 previously unknown super eruptions. Those probably took place about 9 and 8.7 million years ago. This discovery means that the area around the Yellowstone volcano used to face a super eruption every 500,000 years. But over the last 3 million years, the hotspot has seen only 2 super eruptions. It makes scientists believe these catastrophic events are slowing down, or just maybe one is overdue. Anyway, if the Yellowstone supervolcano went off with as much power as it had 2.1 million years ago, it would spit out more than 588 cubic miles of boiling lava. That's more than 4,500 times the volume of Sydney Harbor. That's a lot of lava. Whether it's likely to happen or not is another question. There's no doubt that something is going on with the volcano. The water level changes in Yellowstone Lake mean the caldera is lifting under the surface. And the caldera is what's left over after a volcano erupts and then collapses. The Yellowstone caldera is not just going up, creating a dome-shaped uplift. It also moves up and down in a kind of breathing motion. It might be because the magma is seeping into the crust, or because this magma is heating up the Yellowstone hydrothermal system, making it expand and raise the crust. Yellowstone has the status of an active volcano. Its volcanic explosivity index is 8 out of 10. Such a high number means that if this volcano erupted, it would be an apocalyptic event. Right before the disaster, the ground around the national park would lift. Geothermal pools and geysers would heat up to boiling temperatures and get more acidic than usual. The magma would start to rise toward the surface. At some point, the rock roof of the magma chamber wouldn't be able to resist anymore, and the explosion would kick off. A massive column of lava and ash would shoot up to a height of over 16 miles. After that, the volcano would keep pumping ash for days on end. The mixture of lava, ash, and gas would be hotter than 1800 degrees Fahrenheit. It would travel through the area at a speed of 300 miles per hour, faster than a racing car. The air near the center of the eruption would heat up to 570 degrees Fahrenheit. One of the most dangerous consequences would be ash fallout. Volcanic ash can turn into glassy cement within seconds after being inhaled and getting in the lungs. People and animals would have problems with breathing. Okay, so that's an understatement, just so you know. Buildings would start to collapse under the weight of this dense substance. It would take just several days until a 10-foot layer of ash covered the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. If the eruption was rich in sulfur, an effective sunblocker, it would get so cold there would be no summer in the entire world for the next several years. The monsoon seasons would change. Agriculture would face serious problems. There would be issues with food supplies. Over the past 50 years, the Yellowstone caldera has risen almost 2 feet. It shouldn't alarm you, though. Experts are sure it's a natural behavior for Yellowstone. Periods of dome-shaped uplift are followed by the caldera lowering. Scientists think the supervolcano doesn't present any danger at the moment. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. The probability of the eruption is 1 in 730,000. Safe to say, it's a long shot. Even better, a recent study made the researchers believe the hotspot might be in a state of decline right now, even despite all the breathing and dome-raising activity. Still, there have been tons of discussions about what people could do to prevent the disastrous supereruption from happening. And the most popular and seemingly effective idea was to cool the Yellowstone supervolcano down. Unfortunately, there's a catch. The volcano leaks out only 70% of the heat which comes from its magma-filled chambers, but the rest of the heat stays inside. As soon as it reaches a particular threshold, the volcano erupts. If it was possible to extract at least 35% of the Yellowstone volcano's heat, the eruption could be avoided. The cooler the magma is, the thicker and stickier it gets. It stops being so fluid and doesn't try to get out to the surface anymore. After considering these facts, NASA scientists came up with a plan. They suggested drilling a 6 miles deep well and pumping down cold, pressurized water. The temperature of the water that would get back to the surface would be approximately 662 degrees Fahrenheit. This way, the heat would be gradually extracted from the volcano. And if a geothermal plant was built on the site, it would generate plenty of electric power. It would be very simple to produce, and its price would be very alluring, about 10 cents per kilowatt hour. At first glance, it was an amazing idea, but sometime later, it started to receive a lot of criticism. Imagine drilling through the Earth's crust, getting deeper and deeper, and then wham bam, you hit a hypothermal pocket. Uh-oh, get ready for a catastrophe. This can release gases that are likely to cause a series of super powerful explosions. In the worst-case scenario, it may even trigger a full-scale volcanic eruption. Now, you already know about its catastrophic outcomes, from fountains of lava and avalanches of molten rocks to climate changes all over the globe. Yeah, not good. Or let's say you're drilling a well to deliver cold water to the volcano, and then you suddenly hit its magma chamber. In this case, instead of cooling the giant down, you'll make the top of the magma chamber much more fragile than it used to be, and the whole construction will be at risk of collapsing at any moment. And don't forget that your drilling may also release toxic gases. They often accumulate at the top of the reservoir with magma. Can it get any worse? Well, yes it can. The whole process would stretch for more than 16,000 years. This method is too risky to cool the volcano down as fast as people would probably want. And scientists aren't even 100% sure that when the cooling system construction is finished, the volcano will stay cold for at least another 100 years. And last but not least, the project of making the Yellowstone Supervolcano a bit cooler would cost a mind-boggling $3.5 billion. A huge price for something that might not work out altogether. Oh, by the way, Yellowstone isn't the only volcano that has a lava dome that's lifting at the moment. Lava domes are created when magma gets to the surface and then gathers around the vent. Scientists have found one of those inside an underwater volcano in Japan. This dome is more than 2,000 feet high and more than 6 miles wide. Even though the Japanese supervolcano seems to be sleeping, experts don't let their guard down. A volcanic system can go from being calm and docile to teetering on the edge of an eruption in the blink of an eye. Another massive dome is growing in the central Andes, on top of the planet's largest active magma store. The Altiplano Puna Plateau, well, there's a tongue twister, and where the dome was found, is the second highest plateau in the world, and the dome itself is more than half a mile tall. You might wonder how come experts have known nothing about this enormous uplift until recently. The answer is simple. It was hidden within the plateau. It's an arid region littered with volcanoes, and it stretches for thousands of miles. Yep, another case of hiding in plain sight.
It's the 15th of January, 2022, 4:47 p.m. local time. It will start any moment. Here, do you feel these jolts? The South Pacific is about to experience one of the most powerful volcanic eruptions ever recorded by modern instruments. The eruption begins at Hunga Tonga Hunga Ha'api, an underwater volcano in the Tongan archipelago. The eruption itself is enormous. Its volcanic explosivity index is at least VEI 5, with the maximum being 8. It's as powerful as such historic catastrophes as Mount St. Helens in 1980 and Mount Vesuvius in 79 CE. The eruption releases a staggering 2.4 cubic miles of volcanic material and sends over 150 million tons of water vapor into the stratosphere. This amount of water vapor would have been enough to fill 58,000 Olympic swimming pools. Additionally, the eruption generates the fastest underwater currents ever recorded and triggers large tsunamis that struck areas as far as Peru, more than 6,200 miles away from the volcano. And it takes at least 4 lives, with even more missing. But the craziest thing is that just before the eruption, 15 minutes ahead of time, there was a kind of warning. But as it often happens, people simply missed them. 2 seismic stations, about 466 miles away from the volcano, which is pretty far for this kind of thing, picked it up. They figured out it was a Rayleigh wave, which is a type of seismic wave that moves along Earth's surface. This wave was caused by a fracture in the ocean floor, where magma and seawater started to interact under a lot of pressure. That's likely what triggered the eruption. The crazy thing is that normally, volcanic seismic signals are pretty small and can only be detected close to the volcano. But this Rayleigh wave traveled way farther than usual and was much stronger. It means there had to be a massive amount of movement going on beneath the surface before the eruption. While people on the ground didn't feel it, those distant sensors picked it up. And this discovery is great for identifying volcanic threats earlier in the future and for improving early warning systems. If scientists can detect these seismic precursors, they could give a heads up before an eruption happens. That would give people time to evacuate and reduce the chances of injuries or property damage, especially for underwater volcanoes like this one, which can also trigger fatal tsunamis. Now, the eruption was big, but its impact was mostly contained. However, this discovery underlines how important seismic data is for predicting and preparing for these disasters. Even though this precursor wasn't used to issue a warning during this eruption, the idea that we could use this kind of information in real time during future eruptions is really promising, especially for underwater eruptions, which apparently might give us more warning time than we thought. Even though we wouldn't have been able to hear that precursor warning signal, there is a sound so loud it could actually finish you. And while such sounds are incredibly rare, the loudest noise ever recorded was indeed fatal to those who were close enough. On 27 August 1883, the eruption of the Krakatoa volcano in Indonesia created the loudest noise ever measured. It's thought to have been an astonishing 310 decibels at the source. To put this in perspective, a hand drill produces the sound of 98 decibels. The noise produced by a jet engine measures 140 decibels. And the sound of 180 decibels is capable of destroying your hearing tissue. So, the sound Krakatoa produced reached more than 170 decibels at a distance of 100 miles. And sailors aboard a ship just 40 miles from the eruption had their eardrums burst from the sound. The explosion's reverberation was so powerful that it was heard 3,000 miles away. In fact, at a farm in Alice Springs, Australia, over 2,200 miles away, sheep farmers reported hearing what they thought were gunshots. The sound from Krakatoa traveled around the world multiple times. Although no one heard the explosion beyond 3,000 miles, spikes of atmospheric pressure were recorded in places as far away as Canada and England. Those must have been the sound waves produced by the eruption traveling around the globe. Sound above 150 decibels can potentially cause life-threatening harm. In particular, sounds between 170 and 200 decibels can result in lethal conditions, including burst lungs. Anything over 240 decibels could cause fatal injuries, and you don't even want to know what those are. I'll just say that those sometimes happen to cartoon characters, but rarely to people. The scientific explanation behind this is that sound is essentially a wave of pressure, which can travel through both solids and liquids. And, in the case of an incredibly loud sound, pass right through the human body. If the pressure from such a sound is high enough, it can rupture eardrums and internal organs, causing significant and often fatal damage. Now, you probably know how volcanoes sometimes have small earthquakes before they erupt. Well, they often produce this weird sound called a harmonic tremor. The sound kind of hums, and the frequency of the hum gets higher and higher until it suddenly stops just before the volcano erupts. The sound has been recorded at a bunch of volcanoes around the world. But the thing about Redoubt Volcano in Alaska is that its tremor is so intense, people can actually hear it. It's like the volcano is letting out this crazy scream right before the eruption. According to a geophysicist at the University of Washington, the frequency of Redoubt's harmonic tremor is so high that it is barely perceptible as a low bass hum, and that's at its highest pitch. All because the pitch of Redoubt's tremor exceeds that of any other recorded volcano. It questions the limits of the existing models used to explain these phenomena. That's why researchers had to propose a new model to account for these unusually high-pitched tremors. Most volcanoes produce sound when magma bubbles vibrate as they rise through cracks in Earth's crust. But in the case of Redoubt, scientists believe that the harmonic tremor and associated earthquakes occur when magma is forced through a narrow opening under immense pressure. The thick magma sticks to the rock surface inside the conduit, a channel or a pipe that carries magma from a reservoir or chamber to the vent. As the pressure builds, the magma moves upward. This makes it stick again until the pressure forces it to move once more. These sudden movements cause small earthquakes, which, as the pressure increases, occur more rapidly and blend into a continuous rising noise. So it's actually the rocks making the sounds. This new model is important because it could help scientists better understand the eruptive cycles of volcanoes like Redoubt. It could also serve as a limited early warning system. By the time Redoubt began to scream like this, the volcano had already been erupting for a few days. So the tremor might only provide a few minutes or hours of warning before the next explosion. The harmonic tremor at Redoubt reaches an extremely high frequency, then falls eerily silent before the volcano erupts again. This pause occurs when the earthquake activity slows down and the two sides of the fault slip smoothly against one another. Maybe that's when even earthquakes can't keep up anymore. The new model may also apply to other volcanoes, such as the Soufriere Hills volcano on the Caribbean island of Montserrat. The research team is now planning to investigate why the pressure at Redoubt is concentrated in one specific spot. To move ahead in their research, the scientists have created 2 recordings of Redoubt's seismic activity. The first, a 10-second recording, compresses about 10 minutes of seismic sounds and harmonic tremors, sped up 60 times. The second, a 1-minute recording, condenses roughly an hour of activity, including more than 1,600 small earthquakes that had occurred before Redoubt's first explosion with harmonic tremor. These recordings could provide crucial insight into the dynamics of volcanic eruptions and the signals that precede them.
Our planet's biggest and meanest supervolcanoes are waking up. When they erupt, you'll surely notice it, even if you live thousands of miles away from the epicenter. Scientists are worried we might not have enough time to prepare and deal with the consequences of a supereruption. There's some volcanic activity close to the Italian city of Naples. And no, it has nothing to do with the famous Mount Vesuvius, but with another volcano. This one is harder to see as it doesn't have a tall peak like Vesuvius. But don't let this bad guy trick you. It could be way more dangerous than its giant neighbor. It does have a huge crater that's about 8 miles wide. This volcano is called Campi Flegrei, and it's actually one of the largest volcanoes in Europe, sitting under the town of Pasquale. So, Campi Flegrei erupted 39,000 years ago with a bang so massive it spread ash across the whole Mediterranean region. It also caused the temperature to drop by over 16 degrees Fahrenheit across Eastern Europe. It was the biggest volcanic eruption in Europe in 200,000 years. Since then, Campi Flegrei has had smaller eruptions, and the last one happened in 1538. Now the area is full of small craters, hot springs, and bubbling pools, and they're all proof that this volcano is still very much alive and brewing something. Since the early 2000s, the ground in the giant crater and the town nearby have been slowly rising by about 1 to 1.5 inches every year. There were at least 150 earthquakes that shook this supervolcano lately. In May 2024, there was a 4.4 magnitude in the area, the biggest in the last 40 years. Residents had to leave their homes and camp outside, fearing there would be more earthquakes. No one knows how Campi Flegrei is going to behave in the following months or years, but the authorities are organizing evacuation exercises to prepare the population just in case. The Italian volcano looks like an innocent kitten compared to the real giants like Yellowstone. For a volcano to deserve the title of a super one, it must be able to produce catastrophic-scale eruptions and eject huge amounts of magma, ash, and volcanic gases. The Yellowstone giant meets these criteria. Even though it moves from time to time, the Yellowstone supervolcano hasn't erupted for 640,000 years. But when it does wake up, it might erupt with incredible power, about the same amount as 10 huge nuclear power stations can produce. Under the ground, beneath Yellowstone, there's a super-hot area full of molten rock called magma. As more magma moves into a big space called a magma chamber, the ground above starts to swell or rise. When the magma cools down, the ground falls. Between 2004 and 2009, the ground at Yellowstone rose by almost 10 inches, but then it started to slowly go back down in 2010. Scientists aren't sure if it's going to erupt anytime soon. There's also another big volcano called Long Valley in California that has been active since 1980, and it can be a really big threat. Scientists studying this supervolcano found out that before its biggest eruption, 760,000 years ago, the buildup may have taken less than a year. Now, that's bad news, because a supervolcano eruption can have a huge effect on the world, like the eruption of the Toba volcano in Sumatra around 74,000 years ago. It became the biggest volcanic eruption the Earth had seen in 28 million years. It covered parts of Indonesia, India, and the Indian Ocean with a thick layer of volcanic debris, almost like a 6-inch blanket. The amount of rock it spewed out was like stacking nearly 3 million Empire State Buildings. The giant crater it left behind can still be seen from space. All the ash and gases shot up into the air and blocked some of the sunlight. It caused a volcanic winter that lasted about 6 to 10 years. Some scientists think this eruption might have even affected early humans. Around the time Toba erupted, the human population took a sharp dip, and there were far fewer people. Some say this is why all modern humans come from a small group of survivors. According to the Toba catastrophe theory, most early humans in Europe and Asia didn't survive the cold and harsh climate after the eruption, but a lucky group lived through all that in Africa. Not all scientists agree with this idea, and some archaeological and climate records show a different story. Another volcano that changed the world in a big way was Mount Tambora in 1815. The next year went down in history as the year without a summer. It was cold and rainy, and there was snow and frost even in the middle of summer, especially in Europe and North America. This happened because the volcano sent out a lot of sulfur dioxide into the sky, which spread all over the world and made the planet colder. When Tambora erupted, it caused huge tsunamis that smashed homes and took the lives of around 10,000 people. Afterward, about 80,000 more people passed away because of the consequences the eruption had caused in the world. The cold weather ruined crops, so food became really expensive. And because horses were the main way people traveled, the cost of oats that they ate went way up too. Some people even think this led to the invention of the bicycle in 1817 as a new way to get around. The eruption made the Earth colder for about 3 years. Now, even though the Tambora eruption was so powerful, Krakatoa, another volcano in Indonesia, stole the show when it erupted in 1883. It was just easier to spread information about it through telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami, with waves about half as tall as the Statue of Liberty. Now, if we only had 12 months to prepare for a supervolcano eruption, it would be really hard to store enough food and get ready. But don't panic just yet. Supervolcano eruptions are very rare, and the last one happened 26,500 years ago in New Zealand. Scientists think that a super eruption happens once every 100,000 years on average. But the sad part here is that the Earth doesn't follow a perfect timeline. There could be clusters of super eruptions with shorter gaps between them and then longer quiet periods. Since there have already been 2 super eruptions in the last 100,000 years, there's always a chance one could happen again sooner than we expect. Plus, although there are places like Yellowstone and Long Valley where we expect volcanoes to erupt, there are less obvious possible hotspots. In Chile, there's a volcano called Laguna del Maule that has erupted in the past and left behind a huge crater. Over the last 20 years, the ground there has been swelling really fast, rising up to almost 1 foot a year. Some people are worried that this could be a sign of a big eruption coming. But scientists say there's not enough magma yet to cause a super eruption. In Bolivia, the Juturancu volcano is also acting up. It's part of a group of volcanoes that have caused super eruptions in the past. Since the 1960s, the ground around Juturancu has been lifting, but the last eruption was 250,000 years ago. Even though the magma might be rising, it's not enough to worry about just yet. The chances of a super eruption happening during our lifetime are 1 in 1,400, which is pretty low, so you don't need to worry too much. But just like someone wins the lottery every week with very small chances, a super eruption could happen sometime in the future, and when it does, we'll need to be prepared.